Welcome, Heron and Riverside Scholars. Today we're talking about natural logarithms and common logs. So we're going to be talking about this little letter, which is actually a number, and we refer to it as E. It is Euler's number, and it's irrational, like pi, and it occurs when a system grows exponentially, such as population or interest, and E is approximately 2.718 as a number. So what is a natural log, or we're going to see it written as ln? Well, ln of x is actually a log with a base of e instead of a number. So our number there is e, 2.718. Y equals e to the x, the exponential equation, and y equals the natural log of x are inverses of each other. You do have a natural log button on your calculator, which looks like ln, and ln has the same properties as any other logarithm that we've been working with. So now we have common logs. If you ever see log of x, okay, where there is no base number there, that is your common log. And the common log has a base of 10. Okay, so if there's nothing written there, we just assume that it's a 10. Okay, so every log needs to have a base, and if it's not written, we assume the base is 10. There is a log button on your calculator, and its base is 10. There's no button on your calculator that has a log with a base of 3. It is always 10. So if we're going to example 1 and we're going to evaluate these using our calculator, okay, your calculator only has a base of 10, which is our log button, or it has a base of E, which is our ln button or our natural log button. So just simply putting these in your calculator to evaluate them, you hit log 3, and that should give you 0.477. The natural log of 3 is about 1.099. Okay, so hopefully you've taken the time to look for those buttons on your calculator. If you need help, get in touch with one of us during office hours and we'll help you find that, because I know every calculator is different. So since the base of our log is the same as the base of our exponential, these actually cancel out. And it becomes x equals x. In my second one, I have a raised to the log of a. Since the bases of those are the same, they also cancel out. So x equals x. So we're going to use this known information that a log with the same base of an exponential cancel out. So what's the relationship between log and 10? Well, we know that this is a common log and my base is 10, so they cancel each other out. ln and e, we know that the natural log, the base is e, so those are also going to cancel each other out. So let's look at a few examples. Okay, so there's going to be 3 steps to solving these. The first thing we're going to do is condense it using those properties before, where the plus sign was multiplication, the minus sign was division. We're going to rewrite it as an exponential, and then we're going to go ahead and solve it. So we see we have the plus sign here in the middle, so I'm going to rewrite it as 1. So ln, I'm going to multiply these two because of the plus sign, equals 2. Okay, I know this has a base of e. The natural log has a base of e. So I'm going to do my loop-de-loop. So it's e to the second power equals 4x. Okay, and then solve it. So I'm going to divide both sides by 4. And just evaluate this in your calculator. E to the second power divided by 4. So x is going to be 1.847. we move on to b, I've got a minus sign here, so I have division. So if I'm going to rewrite this, I've got x over 2 equals 2. It's got a base of e, so go ahead and write it as an exponential using the loop. E squared equals x over 2. So how do I solve this for x? Well, I got to multiply both sides by 2. And x is going to be 14.778. Okay, I've got addition here in C, so to rewrite this, that's multiplication. Okay, log, there's no base here, so what are we going to assume it is? It's our common log, so it has a base of 10. So 10 to the second power equals 4x. When I rewrite it, divide by 4, and x is going to be 25. Okay, on D here, I've got subtraction in the middle. So remember, subtraction is division. So to rewrite this, I have log base 3 of x over 2 equals 2. Writing it as an exponential, looping it, I get 3 squared equals x over 2, multiplies both sides by 2. So x is going to equal 18. Okay, pause the video right here and try to do the U-try problems 1 through 3. All right, for 1, 2, and 3, here are the solutions you should have gotten. One was a little different, but we did have to add 6 to both sides before we rewrote it as an exponential and solved it. We should have got 1 over 60. Here we had addition, so we knew it was going to be the natural log of 5x equals 9. It's got a base of e, so e to the 9th equals 5x, divide by 5. Should have got 1,620.62. Here we got addition, so it was multiplication again, so it was 2 times x. Write it as an exponential, divide by 2. You should have got x equals 128. Okay, so for example 3, we're going to use the properties above that we learned about where the inverses cancel out as long as the base of the log and the base of the exponential match. So your first step is to isolate. We want to isolate the exponential. Okay, so here's my exponential here. Okay, so we want to isolate that e to the 2x. So the first thing we are going to do is minus 2 to both sides. So I get 4 times e to the 2x equals 14. Okay, we got to get rid of that 4. So divide both sides by 4. So I have e raised to the 2x power equals 14 over 4. Okay, so now I want to get rid of this e. So I'm going to take the log that has a base of e. Okay, so what is the log that has a base of e? Well, I'm not going to write that. Okay, there's another name for it, right? It's the natural log. So I'm going to take the natural log. And remember, when we're solving equations, we can't just do it to one side. We have to do it to both sides. So when we take the natural log of e, those cancel. So I have 2x equals the natural log of 14 over 4. And then I got to get rid of the 2. Why I put in, I have no idea. So we're going to change that to an x. So I divide both sides by 2. Okay, so those cancel out. I'm going to put all this into my calculator to evaluate it for a number. And you should get x equals 0.626. Okay, if you're not doing that, it's just a calculator error. Come see one of your teachers so we can help you out there. It'll be a real quick fix. All right, so for B, we have to isolate e to the negative 2x. So I'm going to start by adding 4 to both sides. So 5e to the negative 2x equals 16 plus 4 is 20. Got to get rid of the 5. So I'm dividing both sides by 5. 2x equals 20 divided by 5 is 4. All right, so now I got to get rid of this e. So I'm going to do the same thing I did before. I'm going to take the natural log of both sides. So when I do that, that e disappears. So I get negative 2x equals the natural log of 4. Then I got to divide by negative 2. So we're going to put this in my calculator to evaluate it for a number. You should get negative 0.693. Okay, for 10, I want to isolate the exponential. So 10 to the 2x. So I'm going to subtract 2 from both sides. I get 10 to the 2x equals 14. Okay, so now I want to use the inverse of this by doing the log with a base of 10. Well, that is just our common log. Okay, got to do it to both sides though, because when I do that, my bases are the same, so they cancel out. So I have 2x equals the common log of 14. And then I can divide both sides by 2. I'm going to put this into my calculator. And I should get 0.573. And for D, what I'm trying to isolate is the 3 to the negative 2x. So I'm going to add 4 to both sides. So I get 3 to the negative 2x equals 9. Okay, so to undo this one, I have to take the log with a base of 3. Okay, so those match. Do it to both sides, log base of 3. So those go away, and I get negative 2x equals the log base of 3 of 9. Okay, now here's where we run in the issue, because in my calculator, I cannot plug this in, right? I can't plug that in because it's not a common log. But I can rewrite this to have the same base, log base 3 of 3 squared. Okay, because 3 squared is 9. So that's a perfectly legal move. And then if we have a log base 3 and a 3 there, what happens? They cancel out. So now I'm left with negative 2x equals 2. Divide by negative 2. X equals negative 1. All right, stop right here and do the U tries 4 through 6. All right, here are the answers for 4, 5, and 6. On 6, we had to do the same thing we had to do on D, where we took the 4 and we make it a 2 squared, so those could cancel. All right.